Hello and welcome. A couple of months ago I got a very interesting mainboard gifted by Niklas. He gave it to me in this box, and ironically the mainboard itself was wrapped into a local newspaper page with death notices. Well, sometimes I am able to resurrect a hardware, but unfortunately resurrecting people is not on the list of my capabilities. That's why let's concentrate on the wrapped hardware instead. The mainboard is a very interesting one. The model is 694T Pro by MSI and is also known under the name number MS6309. Why is this board so interesting? There are multiple reasons. As the name of the board already reveals, it is based on the great VIA Apollo Pro 133T chipset, which was one of the better VIA chipsets ever made and supported all Socket 370 CPUs, including Dual-Latin. I'm actually very interested in it because I was searching for a flexible platform for my test system, and this mainboard could be a very good candidate. It is usually very stable and fast. From the performance point of view, it can keep up with the famous Intel i440BX, but with proper AGP clock divider, so it doesn't get overclocked at frontside bus above 100 MHz. And speaking of AGP, as you see, the AGP slot is a universal one. There were AGP standards for 1.5 volts and 3.3 volts cards. Most Socket 370 systems still supported only AGP1 specification and required 3.3 volts graphics cards. AGP 2.0 with 1.5 volt was common on Pentium 4, Athlon and more modern systems. If you look at this GeForce 4 MX 4000, you will see two notches on the edge connector. This means that this card can be used in both systems, AGP1 and AGP2. With other words, it would run at 3.3 volts and 1.5 volts, dependent on the AGP slot in your mainboard. Those slots had a key according to the voltage they supported, so you wouldn't be able to insert a graphics card which doesn't support the given voltage. Now, this mainboard is so nice as a test machine because it has no keys in the AGP slot and supports any of the voltages. Means in this board I can test any AGP cards. But be careful, some mainboards have a universal AGP slot, like this one, but are actually not compatible with both standards. In this case I already checked the specs and this board is compatible. So, it is very nice to have a universal AGP in a test machine, but this board is even better. Besides all of the PCI slots, it also provides one ISA slot, which of course allows also to test accordant cards here. Unfortunately, there is only one ISA slot, but better one than none. And so I can use this board to test multiple generations of expansion cards all at once, which makes this board absolutely awesome for such use cases. And this is by far not everything what makes this board extremely useful as a base for a test machine. But first, let's address that elephant in the room, or better to say those elephant capacitors which someone tried to solder onto this board. That looks somewhat funny, but to be honest, despite that recapping is one of the most common thing which is done to the retro hardware, it can sometimes be quite tricky. And the better quality of the board, the trickier is the task. In this case, whoever was trying to recap, it made multiple mistakes. First of all, as you can see, the capacitors are physically too big and don't fit. Second, they all stand off quite a lot, more even hanging in the leads, which is not only because the caps physically don't fit. Well, I'll come back to the caps in a minute. Even if they look funky, the board should still properly work, and before we bring it in a shape, let's give it a brief test run. Here, this Coppermine Pentium 3 800 will be the test CPU. A little bit of thermal paste, a Super Socket 7 CPU cooler for an AMD K62, for example, fits Socket 370 as well. For the RAM, I'll take a stick of 256 MB as DRAM. This one is specified for 133 MHz, which the CPU frontside bus is running at. Of course, we need the post analyzer. Oh, the ATX power supply was on and the mainboard turned instantly on as I inserted the power supply connector. But the good news is that there are numbers running on the post analyzer, and the mainboard complains about a missing graphics card. That means that all the other tests, including memory, were finished successfully. Okay, the board is working at least to some extent. And now let's take care of those capacitors. As I previously said, recapping such a board can be tricky, especially if you don't have proper equipment. With the time, the hardware became more and more sophisticated, more traces, more layers, higher clocks, and so on. The signal quality became more and more important, and the boards required better shielding, which was implemented with bigger copper layers inside of the board. That, of course, dissipates a lot of heat. That's why desoldering capacitors became more complicated compared to the older hardware. Due to insufficient heat, the solder cools down too fast, so people tend to ramp up the temperature of the soldering iron and bring too much heat to one spot, damaging the PCB and ripping off the solder pads. After that, the capacitors have to be soldered from the top side, which can be only done in such a funky way, with a blob of solder at the end of the capacitor's legs. Obviously, it's not possible to solder those right under the capacitor, so it remains hanging in the air like this. The right way to do it is to heat up the area around the capacitor using a heat gun, so that the copper planes inside of the PCB are heat up to a level that the solder inside of the holes doesn't cool down before you are able to suck it out. So to be able to recap such a hardware or something newer, you will need a heat gun and an automatic solder pump. Don't go too high with the temperatures, or you risk to damage the PCB. I use 350 degrees Celsius for both hot air and the pump. For lead-free solder, you have to go with 400 degrees Celsius, but then it's even easier to rip off the solder pads. My best tip is practice, practice, and practice. So, the capacitors are all out, and unfortunately most of the solder holes are damaged. Some more, some less. First, let's clean those with some IPA. As you see, some solder holes look really bad. The pads are almost gone. Inside of the board there are metal tubes which are hopefully still intact. Luckily, some solder holes are made for wide and narrow capacitors like this one. As you see, the hole is completely destroyed. There is nothing left where we could solder a new capacitor to, but luckily the hole is doubled and a narrower capacitor can be used here as well, or we just bend the leg a bit to fit it in. I found some replacement caps in my stash. I will use Jamicon capacitors, which are quite good. The set which I have contains 3300 microfarad capacitors, which is more than what was installed here. Well, I don't know what was originally, but at least the caps which were soldered by the previous owner. As you see, they were 2200 microfarad, but in this case, high capacitance is not bad. More important is the ESR value, which should be low. I don't know which ESR values those caps have, but the rule of thumb is the higher the capacity, the higher is the ESR. But the lower the voltage, the lower the ESR. We have 2200 microfarad capacitors rated for 16 volts. Now we will have 3300 microfarads rated for 6.3 volts, which hopefully will keep overall ESR value at similar value. Lower voltage, on the other hand, means shorter life, and the rated voltage must not be below the used voltage. In this case, it should be alright. All of the caps will be sitting on the 5 volts rail, so 6.3 volts rated voltage is okay. Regarding the life expectation, well, so far those Jamicon caps were reliable, but I don't have a statistics over a decade or so. Should be fine. Never forget the polarity. On the capacitors there is usually such a line which marks the negative leg of the capacitor. On the board you should search for a plus sign, or the white part of the circle usually marks the ground. But not always. I had boards where this was the other way around. On this board the positive solder hole is marked with a plus, but if you are not sure, double check with the multimeter which solder hole is connected to the ground. As I mentioned before, these boards dissipate a lot of heat, and it is not only hard to desolder parts, but also solder new ones. It is important to reduce that heat dissipation as much as possible. That's why I suggest to cut the legs of the caps before you solder those, so they don't act as a small heat spreader. This leg I will not cut off because the solder hole doesn't look good. Probably there is nothing to solder left. I will leave the leg as is and if needed bend it later to the nearby capacitor and solder it there. And again, you want that the solder flows into the solder hole and not just stick on the top. You want a good connection. That's why it's a good idea once again to heat up the area around with some hot air. I heat up this one left over and it looks like the solder flew into the solder hole. Probably the solder pipe inside of the PCB left. And we have continuity. Nice. This means this leg can also be cut off. One interesting note about the number of capacitors in parallel, like here. A common question is why manufacturers didn't use just one big capacitor instead of many small ones. I learned this as I designed my A7 VRM project. As I previously said, smaller capacity usually means lower ASR, which is important for stability of power circuits. And so having many smaller capacitors will end up in lower overall ESR than one big capacitor, even though it would need less space and less soldering work. So new capacitors are in place and the board looks almost as good as new. Let's check if it's still working. And at least we are getting the same result. The board seems still to be alive. Very nice. It still complains about missing graphics cards, so let's insert the S3 Trio AGP adapter, a very simple 2D accelerator which I use for basic testing. And we have an image. Pentium 3, 256 MB RAM with clock set to 100 MHz, probably just a default BIOS setting. The battery is dead, so all of the settings are set back to defaults. Before I continue the tests, I'm very curious if this board actually supports 218 CPUs. Luckily I have a Pentium 3 1200 here, which was in a box since a couple of years. I never tried it and I don't even know if it's working. This is a good opportunity, I guess. Something is wrong. Oh no, one pin is broken off. I was hoping that this would be an unused pin or one of the ground pins, but no, unfortunately it is one of the data pins and needs to be soldered back. Hopefully the solder pad is still intact. Maybe it doesn't look too bad. Well, unfortunately the pad on the CPU didn't hold anymore. I tried to solder a very thin wire to it, but the trace disappears inside of the PCB and the surface to solder it on is extremely small. So after a couple of unsuccessful tries, I decided to postpone a 218 test and move on with another CPU, a Pentium 3 1000 copper mine, which should be somewhat slower than the 218, but this build is not planned to be used for maximum performance anyway. It shall be a test rig for various hardware, and in this case I care much more about reliability. That's why I would like to talk about RAM. This board is special in this regards as well. The used VIA 694T chipset has a built-in ECC memory controller, which allows error correction and provides even better stability. I dug through my stash and found 3 ECC-enabled memory modules. Each module is 256 MB and is rated for 133 MHz frontside bus. They are CL3, so not the fastest, although I'm not sure if ECC memory with CL2 latency exists at all. But as I mentioned, this system is all about reliability and not performance records. The ECC memory modules look a bit different than the usual SDRAM modules. These ones are a bit taller, as you see, and they have additional chips required for the error correction. As I said, each module is 256 megabytes, so with all three modules installed, the total amount would add up to 768 megabytes. That is enough to run Linux and even Windows XP on this system. Windows 98, on the other hand, didn't like so much memory. With a patch it would work, but still the 256 megabytes is more than enough and tends to be even faster and more stable. Furthermore, I said this system is going to be my test rig, which means that I will often change the hardware and restart the system. And then I would like to see it posting fast. But usually the more memory is installed, the longer it takes to post, because BIOS counts the memory and does some rudimentary tests. And of course, the less memory is there, the faster does the system post. So I will probably have to install as much memory as I will need. For Linux or Windows XP tests, I will use everything. For DOS and Windows 98, probably only one stick of 256 megabytes. But it's nice to have that option, and especially with ECC. Previously, I mentioned already the variety of slots, which makes this board a good candidate for a test system. There is one slot though, which is totally useless. This AMR slot, which stands for Audio Modem Razor. This slot was used for modem cards back in the days. Maybe you remember that sound of narrowband analog internet connection. I'd wish this slot wouldn't take space on this board and there would be a second ISA slot instead, or at least another PCI slot, but we have what we have. And here is such a small card which allows audio modulation and demodulation utilizing the onboard sound chip. It has two ports, one to connect it to the telephone wall plug and another one is a put through for a telephone. Maybe historically interesting, but mostly useless for my use case. Still, I have this card and could use it just to fill the hole, because we all don't like empty slots and sockets, right? But all jokes aside, the good news for this board is that the designer has chosen the best possible position for this slot, unlike on many other boards, where such a slot is at the very end or above the AGP slot. Here it is right under the AGP slot. Why is this good? Well, usually the graphics cards become quite warm, and it is a good idea to leave one slot empty between the graphics card and the next PCI card. And the AMR slot creates that gap. Even if the modem card is inserted, it is so short that the GPU should still have enough air for ventilation. Usually the chip is somewhere here and would end up in an open space. And even if we would use a card which takes two slots due to a thicker cooler, it would still fit without blocking any really useful slots, which AMR is definitely not. One thing which I would have to keep in mind is the temperature of the north bridge. This board has no cooler from factory, but in case the chip will get too hot, I will have to glue a heatsink on it. As I said, due to its versatile features, I would like to use this mainboard in my daily testing machine, and I have a perfect case for it. I bought it a very long time ago, and it is a rare ATX desktop form factor, which is very well designed if you want to tinker with it. This is an old recording which I never published, but this was how I got this case. A bit dirty and quite yellowed. Inside though, it was in mint condition, so all I had to do is to clean the front panel. I washed it first, got rid of the glue and leftovers from some stickers. Then I decided to retro-bright it, because the places under the old stickers were a lot brighter than the yellow plastic around it. Retro-brighting went well and the panel looked as good as new. And since then, this case was a temporary home for some of my test setups. And why I mentioned this all? Because this was an interesting long-term test case of retro-brighting. And well, after about 4 years, the yellowing came slowly back again, although by far not so much as it was. Meanwhile, I can clearly see where the old stickers were located. But anyway, it still looks quite good, and I would like to use this case to build a versatile test PC with this MSI mainboard. Off camera, I already updated the BIOS. I found the latest version on the RetroWeb and have written it to the flash chip using my T48 programmer. Luckily, the chip was already socketed. And of course I installed a new battery. Time to put everything together. As you see, if the top cover is removed, this case is open at one side, which makes it easy to access the expansion cards to do voltage and other measurements. This is going to be a DOS and Windows 98 machine. I use 80GB IDE hard drive for that, which should be more than enough. This case requires sliders to hold the 5-inch drives, which unfortunately were not included as I got it, so I 3D printed those. I would like to use this PC also to copy floppies, so I'll install not only a CD and DVD drive but also 3 and 5-inch floppy drives. Since this mainboard supports Ultra DMA 100, I use a high-density 80 wires IDE cable for better data transfer rate. The expansion cards will change often in this system, dependent on what I want to test, but for now I'll use this ATI Radeon 9000. This is a faster 128-bit version, which is more than enough for this system from the performance point of view, but the reason why I like this card is because it has a DVI port, which I use for video capturing through my DVI to HDMI USB video device. I have a lot of nice AGP cards which are more interesting than this Radeon 9000, but most of those have only VGA port, and an analog to digital conversion usually doesn't look that good, so for recording DVI is what I prefer. Yeah, the stupid modem card just for fun and to fill the gap. A simple Realtek network adapter for the data transfer. And more of those USB 2 ports because can be useful. This board already has USB 2 on board, but there are only 2 ports on the back, so it's worth it to have more. Fast forward to another day. I installed Windows 98 and almost everything worked out of the box. This system turned out to be super stable and fast. I'm very happy with it so far. VIA chipsets suffer often from bad reputation and some of those are really sketchy, but this Apollo Pro 133T was really not bad at all. Like with any VIA chipsets, it was important to install the VIA 4-in-1 driver first before you install anything else on the system. Then blue screens and any other instability issues shouldn't bother you. After hours of testing, the north bridge got warm but not too hot that I would say it needs a heat spreader. Still, I think I will glue one on it later. As I said, I have chosen this mainboard as a testing platform because I can test many cards on it. ISA, PCI, AGP1 and 2. I can use it to test SD-RAM modules and all the Socket 370 CPUs from Mendocino, Celeron to Tualatin Pentium 3. Aside of that, I realized that there is a LED post analyzer integrated into this board. 4 LEDs which show the post process, where each step is described in the documentation. So I think this is a perfect testing rig for a wide range of hardware. And of course for gaming, this system is also really good. Dependent on the graphics card, it is able to deliver playable frame rates in any games up to early 2000s. And here comes a small grain of salt. With retro systems, the question of high performance is often less important than the question of the low performance, since there are many games from the late 80s and early 90s which are clock sensitive and could run too fast or not run at all. Digger, Wing Commander or Descent to name a few. For those type of games, it would be important to slow down the performance, and on this system it is, let's say, limited. In BIOS, you can deactivate all the cache, which would drop down the performance to something on a level of a mid-range 3D6, which is not bad, but still is too fast for some games and too slow for the others. Unfortunately, the cache option is the only switch to toggle, and it is all or nothing. It would be nice to set the clock multiplier or be able to set the frontside bus down from 133 MHz to, let's say, 66 MHz. But unfortunately, Intel Pentium 3 has a locked multiplier, and the BIOS allows only to overclock the system, but not underclock it. The documentation says that dependent on the installed CPU, the range of the frontside bus clock is set accordingly to its base clock. For example, Celeron Mendocino, which frontside bus clock is 66 MHz, would allow to set the clock from 66 MHz or higher. A Pentium 3 with 100 MHz frontside bus could be set to something above 100 MHz. And for example, Tualatin Pentium 3, which frontside bus is 133 MHz, to values about that, but unfortunately no below. And that is a shame, because setting frontside bus to 66 MHz on such a CPU would allow to slow down the system in more granular steps. There is of course some throttling software out there which allows to slow down the CPU, but for Pentium 3 I never got good results with that. Maybe you want to share your experience with such tools in the comments. I'd be glad to try some of those, preferably something for DOS, because all the clock-sensitive games were made for DOS. Except of that, I'm really impressed by this mainboard and super happy with this system. As I previously mentioned, the post time is also very important to me, and with only one 256 MB stick, the system posts in only 5 seconds. With all 3 sticks and 768 MB of total memory installed, it takes almost 20 seconds. So for tests where I need to restart the system, often I will leave only 1 stick of memory in there. During my tests, I had to replace the Teak 25-inch floppy drive, which I installed previously because it was not reading floppies reliably. I will have to realign the heads on that one, so the Panasonic drive took the place. Also, the DVD-ROM was switched to another one, but that was just made to better fit the slightly yellowed look. There was no technical reasons. And talking of disks, unfortunately, right after I finished the setup, my 80 GB hard drive suddenly stopped working and I had to replace it. I didn't analyze yet in depth what went wrong with this one, but I used the occasion to test a 160 GB drive with this board, and the good news is that it absolutely works. The system completely recognized the drive and didn't show any problems, which often happen on such systems with disks above 128 GB. So another point for this marvelous board. The next issue worth mentioning is this USB 2 card. Ironically, although this VIA card worked totally fine in one of my Intel 440BX boards, it crashed the system completely in this VIA mainboard. This NEC card, on the other hand, which didn't work very well in an Intel board, worked totally fine in this VIA board. Very strange and something I can't really explain. Probably the VIA onboard controller somehow conflicted with the one on the expansion card, but I'm not sure. Another good news is that, meanwhile, I got replacement Tualatin Pentium 3, which I didn't test yet, but I hope to come to it as soon as possible. But this is a story for another day, and if you're interested in that, please write in the comments what else you would like to see me testing on the system. And so far, this is it for today. Thanks to Niklas once again for this great board, and to all of you out there, as always, thank you for watching, and goodbye.